Hi dear students, welcome to today's class. So in the previous video we have started a new topic, that is calculations involving unit cell dimensions, and we have seen an example also. So today in this video also we'll see another example of that same topic. So we'll discuss the example 1.4 in your textbook. So the question is, X-ray diffraction studies show that copper crystallizes in an FCC unit cell with cell edge of 3.608 into 10 to the power minus 8 centimeter. In a separate experiment, copper is determined to have a density of 8.92 gram per centimeter. So calculate the atomic mass of copper. So that is a question. We need to calculate the atomic mass of copper. So first we'll write all the data given in the question. So it is said that X-ray diffraction studies show that copper crystallizes in an FCC unit cell. Okay, so it is an FCC unit cell. So number of atoms will be, since it is an FCC unit cell, number of atoms, that is Z, is given as 4, isn't it? It will be 4 atoms, because in FCC total number of atoms is 4. So it is having 4 atoms. Now it is given as the cell edge. Cell edge is given 3.608 into 10 to the power minus 8 centimeter. So cell edge means it is A, isn't it? A is the cell edge. So A is given as 3.608 into 10 to the power minus 8 centimeter. Okay. Then it is given as, in a separate experiment, copper is determined to have a density of 8.92 gram per centimeter cube. So density is also given in the question, that is density is equal to 8.92 gram per centimeter cube. Okay, so these are the data given in the question. So we need to calculate the atomic mass of copper. So that is the question. We need to calculate the atomic mass of copper. So first we have to write the formula, that is density. D is equal to Zm by A cube Na. This is the formula. D is equal to Zm by A cube Na. Now in this, density is given in the question. Z, that is number of atoms, total number of atoms 4 is given. Then molar mass is not given in the question. That is what we need to find. They asked us to find the atomic mass, isn't it? Atomic mass of copper, isn't it? So atomic mass and molar mass, we can say if it is 1 mole of a substance, then atomic mass and molar mass are one and the same. So molar mass, if we find the molar mass, we can find the atomic mass. Then A cube, A is given in the question, and Na is Avogadro number. So rest all the terms are given. We need to find M, capital M. So we need to rearrange this equation so that we need to find capital M. So capital M, that is molar mass, is given as, all these terms take it to this side. So it will be dA cube Na divided by Z. So this is how you get the formula. M is equal to dA cube Na by Z. Okay. Now here you can see in the question, A is given in centimeters and density is also in gram per centimeter. So there is no need of conversion here, because both the units are same, centimeter and this is gram per centimeter. Both are same. So there is no need of conversion here. You can directly substitute these values to this formula and get the answer. So how will you write? Is equal to, density is 8.92 into A is what? 3.608 into 10 to the power minus 8. Then it is A cube. So you have to cube this into Avogadro number. You know that it is 6.022 into 10 to the power 23. That is Avogadro number, divided by Z is what? 4. So this is how you do. So this is what you get. Now you need to simplify this. We'll see how to simplify this. Okay, first what you have to do is this term you have to cube first. So 8.92 into cube of 3.608 cube, that you have to do, 3.608 cube. When you do that, you will get the answer as 46.96 into 10 point minus 8 into 3 you have to do. This term you don't have to cube, it is 10 to the power. So minus 8 into 3 you have to do. So I'll get the answer as 10 to the power minus 24 into 6.022 into 10 to the power 23. Okay, now divide by 4. So this much you got. Now what you have to do? You have to multiply all these terms, that is this one and this one together. When you multiply, you will get the answer as 2.5. Okay, that is 2522. Okay, 2.5 you will get the answer into this 10 to the power minus 24 into 10 to the power 23 you have to do. So when 10 to the power minus 24 into 10 to the power 23, you will get the powers as 24 plus 23. This is what you have studied in the first year. Okay, that is when you are multiplying the powers, it will be plus. When you divide it, it will be minus. So minus 24 plus 23 you have to do. So you'll get the answer as minus 1, isn't it? So this will be into 10 to the power minus 1 divided by 4. Okay, so this is how you get. Now what you have to do? So this is just a side calculation. Okay, now what you have to do? When you do this divide by, that is 2522.5 into 10 to the minus 1 by 4. Okay, this term and this term you have to do next, that is this number divide by 4. When you do that, you will get the answer as 630.6 into 10 to the power minus 1. This is how you get the answer. Okay, now to remove this, that is you need to if you want to remove this 10 to the power minus 1, what you have to do? To remove this 10 to the power minus 1, you can make it 0 only by multiplying it with 10 to the power plus 1, isn't it? That is multiplied by 10 to the power plus 1. When you do this minus 1 and plus 1, you can cancel, you will get 0 there, isn't it? So for that, you have to multiply it with 10 to the power plus 1. Plus 1 means was what? You have to change the decimal. So plus means which side you will change the decimal. Plus is in the left side. Right side is negative. So left side is plus. So this decimal you have to change it to the left side. Okay, and 1 means first position. So this decimal you have to change the left side first position. So you'll get it as 63.0. Okay, this is how you get, that is gram per mole, because we have taken here, you can see here density, everything is in grams. So this will be gram per mole. So molar mass is 63.0 gram per mole. Now what we have to do? We need atomic mass, isn't it? This is molar mass. We need atomic mass. So if you want to write it as atomic mass, just write the atomic mass of copper. Okay, atomic mass of copper, that will be equal to, it is same number, that is 63.0 U, that is unified mass. Just have to write it as 63.0 U, that is unified mass. So molar mass will be gram per mole, that is this much gram in 1 mole, that is molar mass. So same for atomic mass of copper is also same, that is you just have to write it as U, because 1 mole of copper is having same mass, that is atomic mass and molar mass both will be same, number is same. Okay, just the difference is only in the unit. So this is how you do this problem. This problem is very easy, you don't have to convert any terms here. It's a very easy problem. So the only thing is you should know how to do the calculation properly. That is when you are doing in a normal calculators, you have to do it step by step, otherwise you won't get the answer. Step by step when you do, you will get the answer. So this is the answer for example 1.4. Thank you.